Okay, so as we all know, since we're here at ACI, there's a lot of things that we can do with concrete. So I'm going to talk a little bit about concrete's versatility. And so when I think about concrete, the first thing that always comes to mind is something where we have an interstate pavement where we're doing full depth concrete pavement, something that's typically like this. But we can also do full depth concrete pavements in urban settings, rural settings. We can also do it on state roads and highways as well. We can also do it on local roads and city streets. And that's really what the ACI 325 guide is really all about. But in addition to that, we can also do overlays, which Peter's going to talk about here in a minute. And overlays can be a whole different monster in what you can do with them. You can do thicker overlays that are unbonded from the subsection below you, or you can do thinner overlays that are actually bonded to the asphalt pavement or concrete pavement below it. And you can also do thinner overlays that have shorter joint spacings that can also reduce stresses as well. But in addition to those full depth sections, we also have intersections where we can use concrete in different ways, and here we start to get into jointing issues and how we're actually joining the pavement to reduce the stresses. Another shot of the intersection as well. We also have any place where we have interchanges. And there the design for the concrete pavement isn't just about thickness, it is about the jointing as well. How do we make sure we reduce the stresses and don't get cracking and faulting within that pavement? And we have intersections. We also have roundabouts. So roundabouts are another big place where we're considering how the pavement is going to be reacting to our loading scenario as well. But in addition to those full depth and overlay type concepts for concrete pavements, we also have other types of facilities that concrete can be utilized in. Those site paving type facilities, industrial pavements, heavy trucking facilities, all can be designed with concrete and built with concrete. We also have parking lots where we're typically seeing just smaller, lighter traffic. We also have different materials that we can do. We have roller compacted concrete, like Ryan mentioned. We also have composite sections where where we're either putting concrete on top of cement treated base or full depth reclamation, or we can actually put asphalt pavement on those as well. So there's a lot of things that we can do with cement. We can also have pervious concrete pavements. So when we're thinking about all these different options that we have for city streets, local roads, intersections, all these different types of facilities as well, we really need to remember, what are we designing for? What are we designing for? We can do certain aspects of the design pretty well, but if we don't think about everything, we get into a situation like this. It's not going to work out really well. So that's what we're here to talk about. We're talking about which design guide, which place we're going to get the right design for the concrete that we're trying to build. And so designing for what, I'm going to briefly cover some of the stuff that Brian mentioned as well, but I'm going to go into a little bit more detail. But we can design for streets and local roads. We can design for parking lots. We can design for industrial and trucking facilities with really heavy loads. We can also design with roller compacted concrete and pervious concrete pavement. And ACI does have guides for all of those that cover things pretty well. But there's also other tools out there that you can actually use to actually design these things. And we're going to talk about one of them in detail, and I'll talk briefly about some of the other ones as well. But we'll talk about Pavement Designer here at the end as well. Okay, so the first section that we're talking about, streets and local roads. What Brian talked about, we're talking about the subsection, we're talking about bases and how we actually build the substructure for our concrete pavement. That's covered in that ACI 325 12R document. And so in there we're talking about the guide to the design of jointed concrete pavements. There are other documents that Brian mentioned on construction, mixtures, overlays. Peter's going to talk about the overlays here in just a minute as well. But there are other ways to design those pavements as well. We have Pavement Designer, which I'll talk about. We have ASHO 93 and Pavement ME. There's also a tool called OptiPave that can do these sections as well. So when we're thinking about a street and local road, one of the big benefits of having that ACI 325 guide is it's really focused not just on the thickness design, but all the different aspects of getting to that thickness design and the other things you need to consider, like jointing. When we look at the ASHO methodologies, the ASHO 93, the Pavement ME, those documents, or those design procedures, those are really more meant for highway type facilities, your interstates, your more heavily trafficked facilities. So they may not be quite as applicable when we're talking about concrete pavements for lower volume roads like we see with this ACI 325 document. There's also the OptiPave tool, which can kind of get to some of those thinner sections that we're looking for when we have these lower volume roads. So if we look at ACI 325.12, Brian mentioned what it does for your substructure when you're looking at your base and your subbase and how those need to be designed. But it also goes through thickness design, where it looks at traffic, classification of that type of facility, thickness determination. It also goes through economic factors as well. In addition to that, the new guide that they're they're writing right now also goes through some of the environmental impacts, and also looks at life cycle assessment, which is some of the things that are becoming very, very important when we start talking about places that are very interested in climate change. So it does have some of those aspects as well. So if we look at one of these tables, this is actually from the new design guide that is not out yet, but the tables are very similar from the old existing guide. You can see the first thing that we have to look at is our traffic classification. We need to look at what type of facility we're actually designing for. So we have light residential, collector streets and local roads, major and minor arterials, and we also have business classification. And so within that, we need to determine what our actual traffic is going to be. How many trucks per day are we actually looking at? So that's what that's saying. Our average annual daily truck traffic. You can see this gets higher when we get to the higher type of facility that it is. So once we have that, we then need to look at what type of support system our pavement is being built on. And so we have K values of 100 psi per inch. We also have a corresponding CBR value. And then from there, we can actually, we have to determine what kind of strength we're looking at for our concrete pavement. What's our flexural strength? So we have options of 500, 600, and 700 psi. And then with that, we can get our thickness of our concrete pavement. We also have, in the new guide, a maximum joint spacing right in the table there. And some of this is still being worked out, but the tables are largely what's going to be in that new document. And so it's a fairly easy way to get at the design you're looking for. And the big benefit of this is it bare nuts and bolts of what you need to do for designing a street and local road. Now, one of the drawbacks of designing with these tables is it kind of limits you in terms of what you can actually do. You're set at a locked reliability, and you also have limited options for your number of traffic. You're also set to be using these set traffic classifications. And I'll touch on that in just a minute. And so the rest of the ACI 325.12 document talks a lot about jointing. There's a lot of different aspects of jointing that can make or break a concrete pavement's performance over the long term. And that's where having these maximum joint spacings right within the table is starting to help with that. But we also have other types of joints. That maximum joint spacing is really looking at our transverse joints. We also have to worry about our longitudinal joints, whether or not we have some odd-shaped slabs and how we need to deal with those. We also have isolation and expansion joints, whether we have those irregular slabs, and whether or not we're sealing our joints as well. Okay. All right. So moving on to parking lots. So we talked about streets and local roads. Next up is parking lots. And so parking lots, obviously a little different from our streets and local roads depending on how the traffic's going to be actually going in and out of them. So ACI 330 really covers concrete parking lots and site paving. The 330 R08 guide, which they're updating right now, which should be pretty close to ballot, covers this design as well. The other thing that really focuses on parking lots is Pavement Designer. Again, Pavement Designer is kind of the all-encompassing tool that can really do a lot of this stuff. So if we look at that 330 R08 guide, their document, again, looks at a lot of the same stuff as the streets and local roads one, but it does accommodate a few other things. First off, it looks at stresses a little more detailedly, for the concrete parking lot type of facility. It also looks at loads and subgrades just like our 325 document does, and then it gets into the thickness design. It goes through jointing a little bit, and it also goes through steel reinforcement because that's a little more prevalent sometimes in parking lots, whether or not it's actually warranted or needed. But it does discuss that as well, whereas in 325 we're talking more about doweling our joints. And then we also talk about grades in there, since we're also talking about very significant sections of concrete and how we actually get moisture on and off those sections. So we also talk about materials and construction, inspection, maintenance, and repair and cleaning. Obviously, when we have these large sections of concrete, it's very important to maintain them and repair them and keep them in a good state of practice as well. Okay. So our industrial and trucking facilities are also covered by the ACI 330 committee, and they have another document that's the ACI 330-2R17, which just came out 2 years ago. And that's the guide for design and construction of concrete site paving for industrial and trucking facilities. So this is looking not quite at like parking lots, it's looking at higher volume or higher level of traffic and more significant loading. And so when they go through their document, they also talk about different ways that you can design pavements. They actually use a very similar method, or they use kind of the basis for the methodology of Pavement Designer, which is another way to design these facilities. But they also talk about tools like OptiPave, which can do the same, or can do design for this type of facility, as well as AirPave, which is also kind of featured in Pavement Designer. But more on that later. So the ACI 332R17 guide, again, has this very similar structure from the other guides, goes through subgrades and subbases, just like Brian was talking about, and then it goes into the pavement design where they get a little more detailed into into reinforcement of the concrete, as well as stability and load transfer. And so in there they also talk about reinforcing their joints and making sure that they get some good load transfer, especially when they're looking at harder, smaller plastic or steel wheels rather than our typical over-the-road traffic where we have pneumatic tires that we typically see over the road. So there again, we have materials and mixtures, and we also have construction, inspection, maintenance, repair, and sustainability as well for that type of facility. So then our other type of materials, we also design these in streets with roller compacted concrete or pervious concrete pavement, but they're a little different. So we also, those are covered by two different committees. So we have ACI 327, which covers roller compacted concrete. The 327R14 guide is the guide to roller compacted concrete pavements. The other way to design these pavements is with Pavement Designer, which we'll show in just a bit. Okay, so with RCC, the 327R14 guide goes through the uses for RCC, one of those being streets and local roads, but also highway shoulders, parking facilities, industrial and intermodal sites as well. So there's a lot of different things we can do with RCC. But it also goes through the properties of the material and the mixture and proportioning. As you can see, this isn't quite what we're used to seeing when we do conventional concrete pavements. This is a drier mix. It's a very low slump or a zero slump concrete that we actually a lot of times put down with an asphalt high density paver. And you can see that mix is different from our conventional concrete, so it focuses more on that mixture proportioning and the material properties of that RCC. And so it also goes through structural design, where it also uses a tool called the predecessor for Pavement Designer, which is Street Pave. So it's based on that same methodology that we'll talk about in a second with Pavement Designer. But it also talks about some other tools that are available for doing this type of work. It goes through RCC Pave, which is an older design methodology from the Portland Cement Association. I'm not sure that it's quite available anymore. It's really hard to find, but it can be used. And then it also goes through PCASE, which is the Corps of Engineers design tool for concrete pavements, and that's because RCC is used as well for airport type facilities, as well as other type of pavements that the Tri-Services use. Okay, so our last type of concrete pavement or concrete application pavement. And so there are ACI 522 goes through pervious concrete, and they have a few different guides that report on pervious concrete as well as a specification for it. And you can see what we're really using pervious concrete for is for that stormwater management, where we need to actually store and kind of utilize that pavement to actually use and store that stormwater that comes out of there. So the other ways to design these types of pavements, pervious pave is a good one, and that kind of follows along with the pervious concrete, the report, on pervious concrete, and we'll talk about that in just a second. We can also use the structural design for Pavement Designer as well. And so 522R10 goes through the applications, again, very similar to what we've been talking about, our streets and local roads, parking facilities, and it goes through the material and properties and mixture proportioning. You can see here, it's again very different from our conventional concrete because we have low fines, trying to be able to create a void structure, moisture, and still carry a load. And so it goes through that and how we do that. And so it also goes through the pavement design. The structural design is very similar to our streets and local roads, as well as our RCC design. The big difference here is you also have to consider a stormwater management design. So we're not just talking about carrying the load, we're talking also about storing the water. And so that's the big benefit of the 522R10 guide, is that it covers that stormwater management It's also covered within the Pervious Pave tool that's available as well. Skip that. Okay. The rest of the 522R10 guide goes through construction. Construction of this type of pavement is a little different. A lot of times we see a roller screed being used to put it down, or some type of screed to consolidate it and compact it a little bit. But we still need to make sure that the void structure is there to make sure that we can allow for that, the carrying of that storm water within the pavement. It also talks about jointing and curing of this, curing being very important with this to make sure that we get the strength that we need and make sure that this structure just doesn't just crumble and can actually carry that load. So it also goes through performance. It also goes through some of the limitations with this type of pavement and what you need to do to make sure it performs, where a lot of times we need to make sure that that it doesn't get clogged up with debris or anything from the underlying section, the subbase and substructure, clogging up the void structure within it to make sure that it can still take in that moisture and that water. Okay, so with all of those different types of facilities, the streets and local roads, the parking lots, the heavy industrial facilities, as well as the other types of materials where we're looking at RCC and pervious concrete, one of the tools that's out there that can do most of that stuff is pavementdesigner.org. So pavementdesigner.org is a free tool that was developed by the concrete pavement industry. It was built in collaboration with the National Ready Mix Concrete Association, as well as the American Concrete Pavement Association, and the Portland Cement Association, with a little extra funding from the RCC Pavement Council to make this thing a reality. But this tool is really developed to be a free tool to design just about every type of concrete facility that concrete pavement facility that we can design for. So it covers the parking lots, it does roadways in terms roadways, and with that it can do jointed plain concrete pavement, roller compacted concrete. It can also do continuous reinforced concrete pavement. It can also do the overlays that Peter's going to talk about in a little bit. It can do those thinner sections with the bonded sections. It can do the unbonded sections as well. And we also do the composite pavements where we're looking at a cement treated base or full depth reclamation with a concrete pavement on top or an asphalt pavement on top there. Excuse me. And then we can also do industrial and intermodal yards. And so the big difference here is that with Pavement Designer, we can actually design for forklifts or other odd type loadings, whereas most of the other design tools that exist, are really more built for your conventional over-the-road trucks, as opposed to some of these heavier loaded type of vehicles like a forklift or a container handler that may not be covered by either the ACI guides or other design tools. So, a large basis of Pavement Designer is it's built primarily on the Portland Cement Association's design method that was originally developed in the 1960s. It's evolved over time. In the 1980s, an erosion model was developed to take care of, to kind of evaluate the faulting that occurs within concrete pavements. In 2005, it was released as Street Pave in a software form, and in 2012, it was revamped with a few different features, including reliability as well. And so in 2018, we kind of stopped developing Street Pave, and we created this Pavement Designer tool, which is, again, an online and a free resource, whereas Street Pave used to be a tool that you'd have to pay for. And so Pavement Designer incorporated this design methodology as the basis for it. It also incorporated a few other methodologies to be able to cover some of those other types of facilities that we want to design with concrete pavements. And so with Pavement Designer, the big thing that we look to design for is the cracking and faulting. And so we have both erosion and fatigue models within it, but the basis for Pavement Designer is a mechanistic-based design. It's a mechanistic empirical design. And so when we do that, we can evaluate how different types of loadings actually impact the pavement, and we're not just relying on empirical evidence. And so Pavement Designer actually incorporates a lot of the traffic spectrums. If you remember the table that I showed from the 325 guide, it has those spectrums built into it where we can see the actual axle loads that are in a spectrum and then the number of those axle loads that our pavement's exposed to. And you'll see how that looks in just a second. But the benefit of doing that is then we can actually calculate the stress that our pavement sees based on each of those types of axle loads. So each axle load causes a little bit of stress within our pavement, and that's how we can determine how thick our pavement section needs to be by limiting the ratio of stress to concrete strength. So our erosion model is a little different, but it's a very similar concept. Each of those axle loads within a spectrum causes a little bit of damage, and the damage accumulates over time. And so that was developed later on in the 1980s, and the reason it was developed later on is because our earlier concrete pavements were primarily built with dowel bars, and so we didn't see a whole lot of faulting. Around the 1970s, we started pulling the dowels out, and we started seeing faulting, and so we had to develop a model to actually evaluate that. Okay, so actually that looks okay. So now I'm going to show you a little bit of Pavement Designer and what it can actually do. I would do a live demonstration, but Pavement Designer works best on Chrome and Safari, and unfortunately our laptop up here only has Microsoft Edge, so there are a few little loading issues with that. But if you have if you have Google Chrome or Safari on your computer, you can access Pavement Designer for free and start designing concrete pavements without even creating an account. You can just go online and start designing any of these types of facilities. So anytime you go to pavementdesigner.org, you're brought to this home screen where you can just start designing a concrete pavement. Over here on our left, we have our other options where we can actually sign in and create an account. If you do that, all we require is an email address and a password, and that way you can save your designs right online. We also have a resources section and a support section as well. So once we click on Start Designing, we're brought to the next screen where we can determine what type of project we're doing. Are we talking about a parking lot where we talked about the ACI 330 guides? Are we talking about a street and a local road where we talked about kind of the 325 design guides? Or are we talking about an intermodal industrial facility where we kind of covered that with the 330 design guides? So each of these tiles has a little flip screen where it gives you a little more detail on what's featured within that design that project type. So you can see here with the flip screen for the concrete streets, we can design for jointed plain concrete pavements, CRC pavements, or roller compacted concrete pavements. We can also design for overlays or composite pavements within this design section as well. So if we go into concrete streets, you can see we can design for our overlays, we can design for new composite pavements as well. And these have those little flip screens as well to just kind of guide you through where here we can do jointed plain concrete pavement or roller compacted concrete. If we click on the overlay one, it can talk about it talks about how you can design for bonded or unbonded overlays. The new composite section talks about that as well. So once we choose full depth concrete pavement, you can see that we're brought to our actual design screens. And each design section is brought in with a three-step process. We have our project level details, our pavement structure details, and our summary details. And so within our project level details, we're looking a little bit about the traffic, a little bit about the trucks per day, as well as our global inputs in terms of reliability and percent slabs cracked at the end of our design life. And so the first thing is our spectrum types. And so we talked a little, or I showed in the 325 tables how it had those different spectrums. Well, Pavement Designer has those spectrums built in where you can select which type of spectrum you want. And you can also have, if you hover over each of these inputs, we have a little pop-up help screen that gives you a little more information. And you can see the little details on some of those spectrums that are in there, what the ranges, what the typical ranges are, as well as what the expected truck traffic is in there as well. And so it goes through that a little bit in more detail with those help screens. And so here I selected a collector traffic spectrum, and when I do that, it actually updates that the spectrum details update over here on the right-hand side of the screen where we have our axle loads, what the actual axles are that we're expecting on our pavement. Got it. And then we also have the number of loads that we're expecting within the concrete pavement as well. So our next input is our design life, typically around 25, anywhere from 25 to upwards of 40 years. This is another benefit of using actual Pavement Designer as opposed to the ACI guides. Whereas in the ACI guides, we have to set a design life. Here we can actually change that design life and look at higher or longer life designs or shorter life designs if that's what you need as well. The next input we have is our trucks per day, and this is that average annual daily truck traffic. So here we put in 100. We have a traffic growth rate if our pavement is expected to see more traffic over time. If the area is building or growing, we might see a traffic growth rate of anywhere from 1 to 3 or 4 or even 5%. We also have directional distributions and design lane distributions. And so that directional distribution and design lane distribution is basically saying 50% of our traffic may be going northbound, 50% southbound, and that design lane distribution is if we have 2 lanes going in the same northbound direction, we may see a larger percentage being in the driving lane, a smaller percentage being the passing lane. So we also have our reliability and percent slabs cracked. And so once we do all that, we can actually get our calculated traffic results. This is basically telling you the total trucks the average trucks per day that we'll be designing for, as well as the total trucks in the design lane over the entire design life. And so once we have inputted all of these within the first screen, we can move on to our pavement structure details. And here, if we're in streets and local roads, we have that option of designing for a jointed plain concrete pavement, an RCC pavement, or a CRC pavement. So we're just going to stick with jointed plain concrete pavement. And so here we actually get to our pavement structure. So we're actually building our structure. So we start off with our subgrade details. Here we can define it based on the resilient modulus value that Brian talked about, or our CBR value. You can also design it with the R value as well. And so we can put that in directly, or we can calculate it based on a CBR value. We also have those help screens that pop up and give us a little more information on what might be a good range for those values based on our engineering classifications. Okay, then we need to put in our concrete strength, and we can define that one of 4 ways. We can do flexural strength, compressive strength, modulus of elasticity, or split tensile strength. And once we input that, we also need to put in our modulus of elasticity as well. And then with Pavement Designer, we can actually design with or without macro fibers, and we can design with or without edge support. So if we had a tied curb and gutter or a concrete shoulder, we would consider it to have edge support. If it's a free concrete or if it's a free edge within our pavement, then we wouldn't have edge support. And so finally, we define our structural layers. That's anything between our subgrade and our surface level concrete. And within Pavement Designer, you can have up to 3 layers. So if I wanted to put a granular base and then say a cement treated base on top of that, I could do so, or I could just have 2 different types of granular base within there as well. So I'm going to put 1 layer in there. I'm going to determine it to be a granular base, and then I need a resilient modulus, which we have defaults within there for each type of layer, and then we also can put in a layer thickness. And so when we do that, Pavement Designer calculates a composite K value where it's taking all of these substructure layers and combining it with the resilient modulus value to give us our full support system. And you can see our K value is calculated there. We can also override that K value if we determine that's maybe a little high for what we were expecting. We can actually override it with our own a user inputted K value, and then we can get to our summary details. And so within our summary details, we can actually take a look at our calculated minimum thickness, our recommended design thickness, as well as our maximum joint spacing, and we can determine if this is what the design we want to go with, or we can actually look at our sensitivity reports where we can see how that design would change based on some of the major inputs that we have. And so with Pavement Designer, there are other analysis and guidance. We can look at our cracking and erosion reports, load transfer. It gives a little more detail on that. We can also save the design and create a report right online. So that's a little bit on Pavement Designer and some of the ACI guides for designing concrete pavements. If there are any quick questions, I'd be happy to answer them. So the question was, within Pavement Designer, does it account for a cement-treated base versus just a general compacted base? And the answer is yes. Within those layer types, one of them is cement-treated base or full-depth reclamation, where you can design for those, and you can put in those properties right in there as well. So it designs as well. Alrighty, well, thank you.